Alright, this is the second video for assignment number 42, and we're going to look at going from both exponential form to logarithmic form and from logarithmic form back to exponential form. For b greater than 0, b not equal to 1, x greater than 0, and y any real number, log base b of x is equal to y is equivalent to b to the y power is equal to x. And this is just going to practice going back and forth between the two forms. It just takes a little bit of practice. It's not hard. Alright, so I got a table here. We're going to identify what the base is and what the exponent is. We're going to either be given an exponential form or a logarithmic form, and we're going to convert to the other. So we're going to start out with being given the exponential form 2 to the third power is equal to 8. The base here is 2, and the exponent is 3. So it is log base, okay, and the base here is 2, of, and then it's always equal to y, and y is the exponent. So what is our exponent here? It's 3. So the only other thing to do is we're missing the 8, so that's the argument in there. Okay, what some folks like to do is they say, okay, well, 2 to the third power is 8. Okay, and maybe you make yourself a flashcard. This is on one side, this is on the other. So you have the log form and the exponential form, and you just quiz yourself. Do you remember where all the parts go? Alright, let's do a couple more examples. Let's say we have 4 to the minus 2 is given as 1 over 16. So if we identify the exponent there is 4, sorry, not the exponent, the base there is 4, and the exponent is minus 2. So it is going to be log, and then the base there is 4, of something, and it's always equal to the exponent, which is minus 2. So the only number we're missing is the 1 over 16. Alright, let's try another one. 10 to the 6th power, 10 to the 6th power is 1 million. The base there is 10, and the exponent is 6. In logarithmic form, it's going to be log, and your base is 10, of something, and it's always equal to the exponent. So 1 million goes inside the logarithm. Okay, now if you recall from the last video, log base 10 had its own special notation. It was just log. Log is base 10. So log of 1 million is equal to 6. Alright, let's try one more. Let's say that we have e raised to the 7th power is approximately 1096.63. So the base there is e, the exponent is 7, and so we have log base e, and remember the log is equal to the exponent, so it's going to be here, I rounded, so that's why we have the little squiggly equals for approximate. So this is approximately 7, log base e of what? 1096.63. Now, if you remember from the previous video, log base e had its own special notation. That was the natural log, not h, natural log ln of 1096.63 is approximately 7. Okay? This is going to be a short video. I got a couple more examples. We're going to go from the log form to the exponential form. So we're going to go ahead and make our table again. So our base, our exponent, logarithmic form, and exponential form. Okay, this time I'm going to start out with the log form. So we're going to have log base 8 of 64 is equal to 2. So that's provided for us. Okay. In the previous video, we actually figured out what log, I don't know if we did log base 8 of 64, maybe it was log base 4 of 64. Anyways, getting off track here. Alright, so let's identify the base. The base is 8, and the exponent, the logarithm is always equal to the exponent, which is going to be 2. So, is 8 squared equal to 64? That's correct. So, you got your exponential form. Alright, let's try another one. Log base 5 of 1 over 125 is equal to negative 3. Okay, so that's provided for us. The base here is 5, and the exponent is negative 3. So is 5 to the negative 3 equal to 1 over 125? It should. and we can always verify this. So 5 to the minus 3 is equal to 1 over 5 to the third, and 5 to the third is 5 times 5 times 5. 5 times 5 is 25, times another 5 would be 125, so that is in fact correct. Okay, I think we got 2 more. We're almost done here. Alright, so we're going to do the natural log of x is equal to 16. So you got to be a little bit more careful here. Ln always is base e, so the base here is e. The log is always equal to the exponent, so the exponent is 16. So we have e to the exponent of 16 is equal to x. Alright, one more. Let's do the log of the cube root of 10 is equal to 1/3. Okay, you don't see a base there, so if you don't see a base, it's either going to be e or 10. Ln is going to have a base of e. Just standard log is going to have a base of 10. The exponent there is what the log is equal to, which is 1/3. So this is going to be 10 to the 1/3 is equal to the cube root of 10. And that's true. That's just how we go from the radical notation to the exponential or rational exponent. Okay. Alrighty, that's it for this video. We'll see you next time.